Hello everyone, it is Mike Levin on Saturday, June 11th, 2022. Another in a series of videos talking about tech and sci-fi apparently. So in my last video, I started out trying to give you the 10,000 and the 40,000 and like from the Kuiper Belt view of technology. And I think I gave some very good sci-fi book recommendations, 3 from Werner Vinge and 3 from the, I guess, dystopian genre, the warnings to humanity. And those are good book recommendations. However, it's probably time to kind of reel it back into what it means for you today. Well, my tune isn't changing. It's Linux, Python, Vim, and Git. There's an average distribution curve with the center line representing most things most of the time, often referred to as the 80-20 rule. If you get proficient at certain bits of Linux and a fairly good amount of Python and a heck of a lot of Vim, and then enough Git to squeak by, you have a safety net in tech for the rest of your life. Timeless, impervious. How can you say that, Mike? Nothing changes in tech. Well, Vim doesn't. VI. It changes a little. It's additive. I went through the whole additive versus disruptive. Like, the stuff in JavaScript's pretty disruptive. You know, big changes in ECMA script, and you have to, at least convert your code. I mean, you could say that about Python, but you put parentheses in front of print statements. It's been fairly minor on the Python front, and it doesn't happen too often. Python 2 to 3, and you think that's going to happen again anytime soon? 30 years, version 3. What's Node.js up to? 17, 18? Are they at 20 yet? And how many years? Okay, so some technologies value a non-changing interface. Unix and Linux are like the definition of this. Unix and Linux interfaces don't change the way that piping and command lines work. It just doesn't change. You can hang your hat on it. You can base a career on it. It will never be disrupted. And Python, a little bit less so, but just a little bit less so. Normally additive. Walrus operator and switches. Congratulations. You've got a couple new things which can make your Python code even shorter and more descriptive. So it's so much honestly for the better that even Guido van Rossum, the benevolent dictator for life of Python up until recently, was like, yeah, the Walrus operator is a good idea. In the same sense that the context manager, and for people who don't know what I'm talking about, I'm sorry, but there's certain bits of expressiveness, patterns of expressiveness that are really, really useful, like, try finally. And instead of having to remember all the intricate details, there's a little light touch that alleviates you, that keeps you from having to type all this tedious stuff over and over. And with open is generally the signature of the context manager. And so a little bit of indenting under a with open statement, and you have all this cleanup code that you're kind of spared from for life, and all your code becomes much more beautiful. And some things which were previously explicit become implicit. Explicit is generally better than implicit. Import this, you'll see. But on occasion, implicit is better. So, context manager, Walrus operator, such. And they're not really disruptive. Okay, so that's Linux and Python. What about Vim and Git? Well, VI is part of the Unix standard. I can't keep waving that flag because I don't abide by the POSIX standards. The POSIX standards, POSIX, which stands for Portable Operating System, right? Would have probably been a better name for Unix than Unix, quite frankly. But the POSIX standards, which defines what Unix is, includes VI, but it also includes the Red Hat Package Management System, RPM, a particular way software is distributed. And and it's not the dominant way in the Linux world anymore because of the Debian branch, okay? So I've been talking about competing branches of things in my recent videos. When you talk about the text wars, the competing branches are Emacs versus Vim. When you talk about the NIX operating systems, the competing branches are Linux versus Unix. When you talk about overall systems, I mean, you know, I guess you'd have to look at consumer. Within the consumer space, it's kind of a split between Windows and Unix. Windows and Unix, not even Linux, because Microsoft Windows is proprietary. It's still proprietary. Even though they have the Windows subsystem for Linux, the thing running the show is not one of the NIX operating systems. Even that has to be qualified, because underneath of there is a Minix, which I keep bringing up. I'll make a video dedicated to the secret operating system on your computer. But it's basically, you know, still Windows versus Mac, and Windows is proprietary and Mac is Unix, so it's Windows versus Unix. What other splits are there? I mean, some of the more interesting splits are historic in nature. The split between Lisp and the whole MIT crew. The dawn of computing and artificial intelligence, right? So for those who are not familiar with it, this strange programming language called Lisp that I keep bringing up is actually part of the MIT camp, you see. It's what some people would call the Media Lab. It had some claim to fame in recent years as the place where the one laptop per child, OLPC, the OLPC came out of. I don't think it's a big thing anymore, but it was a fairly noble effort, and it's happening by default now because economies of scale and Raspberry Pi and all that. Probably the Raspberry Pi is what happened to it. One laptop per child, and a guy named Nick Negroponte, who is more popularly associated with this camp of late. However, that's not the actual genesis of this group. And I'm not going to look it up because I'm driving. These names are a mental block. But the inventor of the Lisp programming language in the 50s through the 60s, and his disciples, essentially disciples, in the MIT lab, from which the incompatible timeshare system came from, could have been a wacky alternative technology history, right? Like pseudo histories. What if the Hindenburg didn't crash and blimp travel remained popular? You'll find a sci-fi book from Robert Heinlein, same guy who I mentioned as the author of Stranger in a Strange Land, an important book to read. Everyone should read Stranger in a Strange Land. But another book he wrote called Job, as a reference to, I guess it's a New Testament thing where God is testing Job, and that is an alternative history that has blimps. Very fascinating. Another book by him called Friday, which is a worthwhile read. But me, with my love for the Amiga computer, that was not the first one on the scene. That was a bizarro alternative history. The MIT lab crew with their Lisp programming language, which gives rise to artificial intelligence systems much more readily than other systems because of its meta nature. No distinction between program code and data. Data is program code. You know how in JavaScript you got JSON, JavaScript object notation for data, and then you've got a whole bunch of other syntax for the actual program code. Imagine if they were one and the same, if the JSON of JavaScript was also the programming language. That is more or less the Lisp programming language. So you create data structures, and those data structures imply the running code of the program, which of course are going to do things to data structures which change the running code of the program. Very heady stuff. Out of this lineage of Lisp also came the Emacs text editor, Emacs, which was written by a guy who I'm mentioning more and more in these videos, Richard Matthew Stallman, RMS, the spiritual leader of the free software movement, still alive, still around, one of the heroes of the computer revolution. Speaking of which, read Hackers, Steve Levy, heroes of the computer revolution. I believe they talk about RMS in there. He is very significant for having written Emacs, a text editor that goes hand in hand with Lisp, because Emacs stands for macros, and macros are what's used in writing meta code, macro meta code, stuff that refers to itself. I think, therefore I am. And if you're drawn to that kind of stuff, you'll be drawn to Lisp, which, as another advocate of Lisp points out, Paul Graham, the original programmer of what became Yahoo stores, which was subsequently re-implemented in more modern languages, but it started out in Lisp. It might have been Scheme or some dialect of Lisp, because Lisp is good at writing other languages and is quite incomplete and low level on its own. So one of the first things that's done with Lisp is the writing of other Lisp dialects, the two most popular back in the day being Scheme. Scheme was popular in computer science because the MIT folks who invented Lisp, and who are real big heavy hitters in the space of computing, had their legendary Introduction to Computer Science course, which was of course taught using their programming language, Lisp. But to have a more complete one, so students didn't have to build everything from scratch, building it up from scratch kind of sucks. So they used, thank you, they used Schema, or Scheme. And another dialect is called Common Lisp, you'll encounter if you go researching this. And it's righteous stuff. Paul Graham points out that there's certain tasks. So we all write code because we have some itch we need to scratch. We want to do something with code, be it machine learning or automation or helping run our business better or, improving our lives in some way, right? We don't just code from out of nowhere. We speak from out of nowhere. As human animals, we imitate what's around us. We're imitation machines. And eventually we just start talking from out of nowhere. There's no, you have to start talking, child, so start listening and mimicking people. It's coded into us, and we just start talking and walking and certain other things. It's close to coding, but it's not quite there. And this last step of doing magic, yeah, I'm talking about magic more and more. What is magic? There's no such thing as magic. It's science. But magic is tricks. You know what magic is? Magic is tricks. After you learn to talk, you learn more things about talking. You learn tricks. So the natural human experience brings you so far, and then little tricks like education lead you to literacy. Literacy is a trick. It was a trick long ago of the haves versus the have-nots, right? It's a real social innovation, the notion that everyone should be able to read, and I'm sure not everyone was for it, too. You can bet that those who have, right, the nature of wealth and power. I never even took the course in college, but I remember reading the description of the nature of wealth and power, and part of the description is, those who have want to keep, and those who have not, are kept in their lot in life. And that is the natural order. And I was like, okay, I understand it. I don't have to take the course now. I'll read a few books. And that always stuck with me. The first priority of the haves is to keep. And oftentimes, sub-bullet, to keep the have-nots from getting anything that they have. There's a certain jealous protection that the haves have. That's coming from a place of fear, a place of scarcity, a place of lack of understanding of the nature of the world. Copies of information can be made, and it doesn't take away anything from the original copy. People can become educated, and it doesn't, then they become part of the literate job force, and they might end up taking jobs away, right? So, if you want to know the reasons for people's behavior, look at the zero-sum game. Zero-sum game, what are you talking about? Nash equilibriums. A beautiful mind. Nash equilibriums in game theory are the fact that, people are not going to unilaterally destroy each other because killing your opponent makes things worse for you in the long run. So that's a Nash equilibrium. But zero sum usually means that there's a certain amount of points or prize that gets distributed out over winners and losers, and it's a finite amount of prize. So people are incented to get as much of that prize as they can for themselves. That's where Nash equilibriums come into play. Why is everyone not super greedy then? Because if you're excessively greedy, all those things that have to happen in mammal society get interrupted. Feeding children who can't feed themselves. If the biggest, baddest member of the tribe hoards all the food resources for themselves, all the children die. Then the tribe dies in a generation. So, greed is not a beneficial survival trait, at least not unilaterally. In specific games, then it's the details and nuance, right? It's all details and nuance. So you gotta be giving. And the MIT spirit is all about that giving. It doesn't diminish anyone to let other people have that software for free. So MIT was kind of the gathering point, a stronghold. MIT was a stronghold for the free software movement. You've heard of the Free Software Foundation, FSF. You notice it's not the Free and Open Software Foundation. They never renamed their organization when the idea of open came onto the picture. Open is a concession because free software advocates are like, information is free. Of course it's open. If it's free, it's open. You're not talking about distribution of compiled binaries. We can bring this back to being very hard-hitting technical, and back to Lyra Ye's question about the C programming language. And is that a virtual machine? Well, maybe not technically. However, the fact that C is the language that opened the door to high levels of portability of code between hardware is not unrelated to the virtual machine concept. In fact, some of the virtual machines, some of the C compilers outright use virtual machine technology. They say this is the best way to do it. We're going to separate parts of the process, and we're going to make these parts of the process run by a low level, it's kind of close to the hardware. It's not as thunking down of capabilities. Thunking down of capabilities is an important concept. We have such a high respect for the digital electronics world. Lose a little bit of that respect for digital electronics. Not for electronics. Electronics is profoundly, infinitely subtle. Digital electronics is a bit less than subtle. It reduces things to on or off, ones and zeros. That is not subtle at all. That is binary, my friends. That is not shades of gray. That is not a world of color. That is black and white, extreme contrast black and white. Do you like photographs in extreme contrast black and white? No? Well, that's the resolution of information in digital. It's a lie. It's a thunking process. The dropping of information, the reduction of information, the sampling of higher resolution information to lower resolution information so that it can be handled more easily by the types of systems we're good at building. So we're good at building digital systems, as opposed to what other kinds of systems are there, Mike, than digital electronics? Well, there's analog electronics, there's biological systems. DNA is an information system, it's not digital at all. There's the 4 amino acids that get combined in different, so that's 4, it's a sequencing of 4 different things. That is not binary, my friends. Nature, as well as we can tell it, is not binary too, because there's up spins, there's down spins, there's half spins, there's full. So these interactions of these different states, well, there are these different states. There are not 2 states. It would have been interesting if when we tore down to that, single particle level, what we think is the atomic particle level, maybe photons, if it turned out binary. It did not turn out binary. It turned out superpositions of multiple states simultaneously, big riddles, right? We tore it down to where we would have liked to have found binary, and we found, probability. So the world is way more complex than we like to pretend it is when we do digital electronics. So I'll try and nest out of this one, see if I can do it. The game of unnesting. Where we are today with electronics, analog stuff, other types of computing, losing a little bit of respect for the digital part of digital electronics. There are, in fact, other things on the scene. They're becoming more popular. Old school analog computers are coming back into play. They were never fully out of play. If you've ever heard about the butterfly effect, the impossibility of calculating something based on initial conditions, well, maybe it is possible if it were a digital computer. If you tried calculating that Lorenz butterfly, and after a certain period of time to figure out where the dot is on that plotting of that Lorenz butterfly, kind of like this double orbit thing that occasionally goes around with a large thing and occasionally goes wild and comes back, but always returns to something that looks generally like a butterfly, which is part of where the butterfly effect word comes from. Everyone attributes it to that expression about if a butterfly dies in China, it could create a new weather pattern in Detroit or whatever, But the butterfly effect also comes from when you plot one of the Lorenz strange attractor algorithms, particularly on an analog computer, you cannot predict its movement. And if you run it 2 times with the exact same initial conditions, it might come out differently. That's because of the analog nature of analog computers that it was run on in those days. You can get a Lorenz strange attractor, run it on your Android or iPhone. It's not the same. It's not the same because your Android and your iPhone are digital. It actually reduces all the data to ones and zeros. we've got computers that don't. So of what use are those these days? Well, in the sensors for visual learning systems, for example, you've got something that senses an intensity of light. That is an analog signal, that intensity of light. Is it black? Is it white? Is it somewhere in between? Well, that level of somewhere in between is going to be some sort of signal, probably an electromagnetic signal, maybe a certain amount of voltage. Now, that voltage can go up and down with infinite variety. How do you relay that message to something else that takes action on it? Well, it's a digital sampling. It has to thunk it down to a, black and white number, a decimal. Does it have to? Well, no, it doesn't really have to. You can keep it analog along the line. You can have the sensor connected to an analog device, and that analog device can send an analog signal, and somewhere you're gonna probably need it to be digital. It's hard to imagine it being kept analog all the way down. But when you talk about can a computer ever have a soul? Well, the gut reaction of no is due to our intuitive understanding of the thunking down that occurs in the digital process. No matter how complex something becomes, you have a fairly high degree of confidence you could play it back exactly the way you played it back the first time. Because so many things about initial conditions are reproducible, you see. Not so much with analog computers. So there's a true element of unpredictability, and maybe an allowance made for a real soul. Okay, did I just go into orbit again? I did. Good thing I have my extra caffeine drink. Morning mocha. I'm still nested deep into the discussion. I remember I said I'm going to bring this back to real-world technological things and decisions that you're making. There's different programming languages. The MIT crew represents Lisp. Lisp is significantly different. Lisp is not in the lineage of C and Unix, so there's a schism there. That's the split, and there I just unnested. If you were to look at what is in an opposite camp from Unix, Linux, C, and everything created with C, which would include every proprietary system of today, Python is written in C. You can look at the Python source code, it's C. Windows itself, even though it is proprietary in nature, it's written in a language, that's gonna be C. Everything you know is written in C. So how is there another camp to Unix, Linux, C, and everything proprietary written in C? How can there be another camp? Well, back in the day, these things were written for the hardware it runs on. There was not an interoperable operating system. Take Unix out of the picture, and these things were written for the hardware it ran on. Wait a minute, are you saying that Lisp was actually programmed for, it's a program language programmed for the hardware as if it were some sort of Lisp machine? Oh, I gotta get this guy's name. The father of Lisp. Let's try it in Google. I'm gonna try voice. Who created Lisp?
Sorry, I don't understand.
Who was the inventor of the Lisp programming language? Anyone? Anyone? Who invented the Lisp programming language? No? Oh, I gotta take a look at my map. Yeah, I need to turn left here. Good thing I switched back. All right. Head in the game. Driving always takes priority. There are computing issues right in that. honestly, the executive function that hands control between coprocessors. Okay, Google, who invented LISP? Who invented LISP?
LISP was designed by John McCarthy.
LISP was invented by John McCarthy. How can I not remember such a common name? Maybe because by virtue of it being so common. How can you remember John McCarthy? Well, first you start with McCarthy, because McCarthyism, right? And he's a more famous McCarthy. You know, have you no shame, said some judge to McCarthy, the senator who was going on the witch hunts looking for communists in every location, whether they existed or not. So I will try and make the association there. People who changed our lives. Yeah, that McCarthy had no shame. He went on witch hunts for communists in every walk of life, particularly Hollywood actors, until a judge just finally spoke up. Thank you, judges. Thank you, judges who have a mind of your own. I guess that's what makes them judges, right? They're good at that kind of stuff.
Continue on I-84 for 3 miles.
So this McCarthy, together with a collaborator, and I'll get you the collaborator's name, but they were the father figures behind LISP and the crew of MIT who advocated machine learning, self-referentiality, macros, meta techniques, open software, the incompatible timeshare system, and dun dun dun, who needs an operating system anyway? Is this a discussion of, did someone say operating system? We don't need no stinking operating system. Just implement LISP on the machine. If the first thing you do with LISP is create compilers for LISP, if the first thing you do with LISP is create more appropriate, more domain problem appropriate sublanguages, dialects, then why not the first thing you do with LISP create everything you need for that piece of hardware? Just start putting it together in LISP. Duh. What would you call such a Lisp machine? Who needs a name for it? It's a Lisp machine. Now, I think there's some out there. Wallenpaupack. We're passing Wallenpaupack, which is the artificial lake where Camp Watonka. I went to Camp Watonka as a science camp. So when I was 12 years old, the year before I went to Israel with my friend Guy Brookstein. I went with him when I was 13. Well, no, that was 12, so it was 11 to 12 and then 12 to 13. Yeah, because boy, this is all a blast from the past. But I'm near my one overnight summer camp, an all-boys science camp, where I learned magic from a bunch of Brits who were over as camp counselors.
In half a mile, take exit 30 for Pennsylvania 402 toward Fleming Road, Porter's Lake.
All right. So you say you could listen to computer history from me all day. Does this qualify? Speak up. I only have about 10 more minutes to record on here before this runs out of room, so I'm going to try and wrap up whatever it is I'm trying to say.
Exit 30, then turn left onto Pennsylvania 402 south.
In this rambling all over the place video. Yeah.
Turn left onto Pennsylvania 402 south.
You know a funny thing? Even though the winners can rewrite history, you can't erase information. Information will evaporate in its own good time. But anyone who's concerned with preservation of information, or even recovery of information, archival stuff, right? There's anthropological issues here. Because everything is information, and information is everything.
Continue on Pennsylvania 402 South for 21 miles.
What does matter if things like the Star Trek transporters are one day possible? I'm not thrilled about the Star Trek transporters because you don't want to destroy an individual, or an original copy. An individual. You don't want to destroy an individual. It's only viable if each atom is actually through some, I don't know, maybe spooky action at a distance process, is the same particle. Every particle is the same particle on the other side. If you're just squeezing it through a tiny wormhole, I'm okay, because the one on the other side is not really a copy made from different particles. It's the same actual particles. I would be okay with that if that was a Star Trek transporter. But the idea that it's actually a scan and destroy and a recreate from a pattern, I'm not too thrilled about that. I would not go through a transporter. I'd be like Bones McCoy. No way! You're not scrambling my atoms all over space. Well, if those atoms, if it's a wormhole, okay. Spooky action at a distance where it just has to be squeezed through like a tube of toothpaste, and the copy at the other side is not a copy, but the original. I would probably do that if it's like high level of reliability. What the heck was I talking about? John McCarthy. So I'll remember John McCarthy now because I've associated him with the other McCarthy. So that whole crew was an alternative technological history. Things could have turned out very differently, and some would say better. As good as things are with the Unix and C camp winning, and that's what it is. Let's be honest here. What happened with Fernando Corbato, Ken Thompson, Linus Torvalds, and I should throw in that other guy from the UK who created the BCPL language, and Dennis Ritchie for his part, is one camp. It's the C camp. It's the low-level virtual machine camp. You want to capture the spirit of this thing? Google LLVM. Look at how the LLVM project is incorporated into alternative C compilers to the GCC one. GNU C compiler is the dominant one because it's been around so long. It's from the GNU Foundation. There's a bunch of different related but different foundations. There's the GNU Software Foundation. There's the Free Software Foundation. I guess those are the two big ones that are associated with Richard Matthew Stallman and the MIT crew. Information should be free. The incompatible timeshare system was not what was adopted by Multics. It was not what was adopted by those who adopted Multics because there was no security in the incompatible timeshare system from the MIT crew. That was probably running on Lisp hardware. So there was also commercial Lisp hardware. It wasn't just the MIT crew putting homespun Lisp stuff on their handful of computers from back in the day. As computers matured and were used for more and more purpose, like graphics for movies, and we're talking about the age of perhaps Jurassic Park, when the computer graphics were really becoming convincing, like when you could create characters in movies, albeit on the dinosaurs, with computers, which is really interesting because this brand of computer is what killed the old dinosaurs of the minis and the micros. So everything room size and everything refrigerator size, the ENIAC, Univacs, the Univacs and the PDPs from digital equipment, in fact VAXs, what replaced the PDPs, which were so important. How did those get modernized? The VAX computers. And if you want to talk about a badass alternative computing lineage, we can talk about VAXs from Digital Equipment Corporation, DEC, and VAX clusters, and concurrency in ways that would even be hard to imagine today how much usefulness and functionality it brings to the picture. There's now open VAX because it's so useful, a certain brand of hardcore wizard will not let this stuff die, and more power to them. But it's a different camp. It's not the camp of Unix, Linux, and C. It's yet another schism. But before I talk about that schism, let's talk about the LISP hardware schism. These were pizza box computers they called workstations. Pizza box computers they called workstations. Probably the most popular ended up being in the Unix camp. That was the Sun Spark Station. The Sun Spark Station was like a high-end Amiga. Their own motherboards, their own chips. They did everything from silicon to box, and they were their own autonomous, line of Unix, doing everything Unix did but better. And that's Solaris, and there's now Open Solaris for people who won't let that tradition die. Yeah, go Open Solaris, people. Oh man, I'm so glad I'm covering these different lineages and schisms. But nonetheless, the pizza box computers that were not Spark workstations, the Apollos from HP Apollo, and there were some others. There was MIPS. All these are gone now, but Hewlett Packard probably had one. HP Apollo, no, that was it. That was the Apollo. So these were pizza box computers. It was before the tower computers. IBM compatible tower computers was because of all the expansion cards. These were proprietary boxes without a lot of expansion. You bought them with everything they needed to do the job. Quantel Harry's when it wasn't 3D and it was two-dimensional painting, but 24-bit high-end graphic design stuff. Quantel Harry's. I don't know, would you include Chiron generators? Not really. There was dedicated video hardware that were kind of like computers too, but the Quantel Harrys were definitely computers. And Spark workstations, Apollo Suns, MIPS, and those were Lisp machines. At least some of them were. Some of them didn't have an operating system. Their operating system was the Lisp programming language. When you have Lisp, you don't really need an operating system. It is that much of its own everything. That tradition's kind of carried on in Emacs. Emacs is the text editor of Lisp. When you have Emacs, you don't really need an operating system. You can't say that about Vim or VI it was based on. With VI, it's a very fine text editor on every operating system. But with Emacs, it's a very fine operating system with which you can create some good text editors. That's the joke, right? There's a lot of geek jokes out there. This is one of the good ones. If you're starting young and you want to reach, if you want to stretch yourself and try for the hard stuff before you back off and use my 80-20 rule stuff. See, all my stuff is compromised. I'm not advocating the most wizardly of implements, you see. I am advocating some of the least wizardly of implements. I'm advocating, once you decide to become a wizard, here is a particular starter pack for a wizard. If you're in Dungeons and Dragons mode and you're provisioning yourself for a campaign, Linux, Python, Vim, and Git is like your bag of holding. You need a bag of holding. That's your Git. You need some sort of weapon, your Vorpal blade or what have you. Oh, that's Vim. Vim is your sword for sure. Vim. What would Python be? Python's your food. You got to bring enough food to get through the thing. Python's your food. And so what's Linux? Linux is your transportation. It's your horses. How do you get to your adventure? Without your horse, you ain't getting there. What do you run on? You run on Linux. What fuels you as you go? What is the stuff that keeps you going? Well, that's Python. You need a programming language. Well, when you encounter something, you need solutions. You need actually to be able to swing your sword. Whoosh, whoosh. You need to have your adventures on your campaign. That's Vim. And then finally, you got your booty and your prizes. You defeated your goblins or your dragon or what have you, and it comes time to start dragging things back. Well, you can bring back a lot less than you would like to if you don't have a magical way to get things around. So, it's your bag of holding. More goes in, and then it looks. There's also a floating plate, I believe. They call it a tensor plate, maybe. I don't know. Maybe I'm just associating it with machine learning stuff today. But, you got your basic implements, your basic provisioning for early campaigns. You might provision yourself better later, but getting started, you at least need to have these check marks checked. And so it took me a long time. And they weren't even ready as I was growing up. I got clowns to the left of me, jokers to the right. Here I am stuck in the middle with you, with the Amiga, right? I got Unix born to the left of me in Murray Hill, New Jersey. I got the Amiga born to the right of me in Westchester, Pennsylvania. Well, maybe that's in the West Coast with where the Amiga folks were, wherever Jay Miner assembled his team. Jay Miner, the Amiga person, if I haven't said it enough, is the original creator of the Atari 2600, popular video game machine that brought computers into most people's houses, including my own. No wonder I felt such a connection to the Amiga computer when I started realizing what it could do. It was in the lineage of the Atari 2600. So those people were yanked over to Westchester, Pennsylvania. I don't think it was willingly, and it ultimately broke up the original Amiga team. They went all over the place, different places. The B OS and the B computer, the 3DO, they scrambled and went on to try and recapture the magic. And this is where I'm going to wrap it up because I'm out of storage. You tell me if you want more. I'll tell you about the B OS and the B computer, and I'll tell you about the 3DO and other things. So let me know. Thanks for joining me. Hope to see you again soon. And don't forget to subscribe.